Page 18. Simplify square roots. When simplifying numbers in square roots, try to factor out the following: -1, 4, 9, 25, and 49. Keep trying to factor these out until none of these numbers can be factored out anymore. It can be factored out if you divide the number that's given by one of these numbers and you don't get a decimal. You can factor out -1. We have a negative on the inside to begin with. Let's look at number 2 on this page, the square root of 8. We can factor this as 4 times 2. 4 is a perfect square. To get 2, we just do 8 divided by 4, and that's 2. So then we're left with the square root of 4 times the square root of 2. We have 2 square root 2, and that is our simplified expression. Now let's look at number 6, the square root of 128. So we want to try to take out a 4. 4 times, if we divide 128 by 4, we get 32. 32 could also have a 4 factored out of it. That's 4 times 8. 8 also has a 4. So we break down the 4s we already did, and then we have another 4 times 2. So we can rewrite this as the square root of 4 times the square root of 4 times the square root of 4 times the square root of 2. So we have 2 times 2 times 2 times the square root of 2. That gives you 8 square root 2. Pause the video and try the other problems on this page. Once you've finished those, check your work and then move on to the next page. Page 19. We're still simplifying square roots. Simplify the radicals, do not round, and show all of your steps. Let's look at number 2. We have the square root of 28. So there's no negative, so we can skip the -1. 28 divided by 4 is 7. So we have the square root of 4 times the square root of 7. That's 2 square root 7. Let's look at number 5. 5 square root of 12. So notice we have a number out here outside of the radical. For a moment, we're going to set it aside and simplify the square root first. 12 is 4 times 3. The square root of 4 is 2. We have a 5 that we're bringing down, and we have square root of 3. So at the end, we're going to multiply the number on the outside by the 2. 5 times 2 is 10. So we have 10 square root 3. And let's look at number 8, the square root of 112. 112, you could divide 4 into this. 112 divided by 4 is 28. And we could divide out another 4. So we have 4 times 4 times 7. So we have the square root of 4 times the square root of 4 times the square root of 7. That's 2 times 2 times square root 7. So our simplified expression is 4 square root 7. Pause the video and try the other problems on this page. Check your work and then move on to the next page. Page 20. We're simplifying square roots. Some of the radical expressions could have perfect squares, or they could already be simplified. There's one on this page that is already simplified, and 2 of them that are perfect squares. See if you can find those. Let's go ahead and go over number 4, the square root of 75. If we try to divide 75 by 4, we get a decimal, so we're going to skip to the next number. 75 divided by 9. That also gives you a decimal. So now we're going to try 75 divided by 25. That gives you an integer. This is what we want. So 75 is 3 times 25. Remember, the numbers that you're trying to divide out are at the top. So we have the square root of 25 times the square root of 3. So our simplified expression is 5 square root 3. And let's look at number 8, the square root of 500. So we could divide out a 4. And that would be 4 times 125. 125, we can't divide out any more 4s. We can't divide out 9, but we can divide out 25. 25 times 5 is 125. So then we have the square root of 4 times the square root of 25 times the square root of 5. So we have 2 times 5 times square root 5. That's 10 square root 5. Pause the video and try the rest of the questions on this page. Check your work and then move on to the next page. Page 21. Simplify square roots. Let's look at number 2, the square root of 48. There's no negative, so we can skip that one, but we can take out a 4. 48 divided by 4 is 12. 12 divided by 4 is also an integer. It's 3. So then we have the square root of 4 times the square root of 4 times the square root of 3. So 2 times 2 times the square root of 3. So our simplified expression is 4 square root 3. And let's look at number 6. The square root of 245. So we'll take our calculator and we'll try to divide out each of those special numbers. 245 divided by 4 is a decimal, so we'll go to the next one. 245 divided by 9. That's also a decimal. 245 divided by 25. That's a decimal, and then we'll try 49. 245 divided by 49. That gives you 5. So 245 could be reduced to, or factored to 49 times 5. So we have the square root of 49 times the square root of 5. Our simplified expression is 7 square root 5. Let's look at one more on this page. Number 9. 3 times the square root of 700. Notice we have a number out here already. We're going to multiply that in to our answer at the end. But first, let's simplify the square root. 700, we could take out a 4. 700 divided by 4, 175. That's an odd number, so we can't take out another 4. Let's try 9. We can't do 9. Let's try 25. Yes, it's 7. So we have 3 times the square root of 4 times 25 times 7. So we have 3 times the square root of 4 times the square root of 25 times the square root of 7. We have 3 times 2 times 5 times square root 7. 3 times 2 times 5 is 30. So our reduced radical, our simplified radical, is 30 square root 7. Pause the video and try the rest of the problems on page 21. Then check your work and move on to the next page. Page 22. Simplify square roots. This time we're simplifying square roots with variables in it. When simplifying variables in square roots, divide the exponent of the variable by 2. The quotient is the exponent of the variable on the outside of the root, and the remainder is the exponent of the variable on the inside of the root. So we basically are dividing by 2, and then we have our quotient, and then we have our remainder. We're going to end up with x to the q power on the outside and x to the r power on the inside. Let's look at number 2, the square root of x cubed. We can rewrite that as x to 3 over 2 power. So we'll divide. 3 divided by 2. 2 goes to the 3 one time. 1 times 2 is 2. Subtract, you have 1. There's nothing left to bring down, so your remainder is 1. So your answer is x to the first power times the square root of x to the first power. Now, since this is an odd degree, we could also say that this is the absolute value of x. Because remember, if we had a negative inside the square root, it would be imaginary. This is to specify that we wouldn't have that here. Let's look at number 4, the square root of x to the 12th power. We can rewrite this as x to the 12 over 2 power. The index is always 2 for square roots, even though there's not a number here listed. 12 divided by 2 is an integer. It goes in 6 times with the remainder of 0. So you just have the answer x to the 6th power. Let's look at number 8, the square root of x to the 9th power times y to the 7th power. First we will rewrite it as a rational exponent. So we have x to the 9 over 2 power times y to the 7 over 2 power. So we're going to have our long division problems, 9 divided by 2, and then we have 7 divided by 2. 2 goes into 9, 4 times without going over. 4 times 2 is 8. Subtract, you get a remainder of 1. 2 goes into 7, 3 times 2 is 6. Subtract, you get a remainder of 1. So on the outside we have x to the 4th power and y to the 3rd power. That's an odd exponent, so let's put absolute values in outside the y value, and then we have times the square root of xy. Try the rest of these problems on this page on your own, and then check your work and move on to the next page, page 23. Page 23. Simplify square roots. Simplify these radicals, do not round, and show off your steps. Let's look at number 4, the square root of 405. So let's take our calculator and try the numbers. 405 divided by 4, decimal, try a different number. 405 divided by 9. That gives you 45. 45 is 9 times 5. So we have the square root of 9 times the square root of 9 times the square root of 5. That's 3 times 3 times the square root of 5. That gives you 9 square root 5. Let's look at number 5. 7 times the square root of 108 x to the 9th power. So we have a number out front, and we have a number and a variable on the inside. So what you want to do is split them up. So we'll simplify the number first, 108. We know that 108 is 9 times 12. 12 can further be factored into 4 times 3. So we have 7 times the square root of 9 times the square root of 4 times the square root of 3. That's 7 times 3 times 2 times square root 3. And that will give you 42 square root 3. Now we'll simplify the x to the 9th power. Rewrite it as a rational exponent. Use long division to find the quotient and remainder. 2 goes into 9 4 times. 4 times 2 is 8. Subtract those, you get a remainder of 1. So we get x to the 4th power times the square root of x to the 1st power. Put these two together. Then we get 42 x to the 4th power times the square root of 3x. And that's our simplified expression. Let's do one more on this page. Number 7. We have the square root of 252 x to the 6th power. Separate the number and the variable and simplify them, and then put them back together. 252. Let's see what can go into that. So we divide by 4, we get 63. So 4 times 63. 63 is 9 times 7. So we have the square root of 4 times the square root of 9 times the square root of 7. So we have 2 times 3 times square root 7. 6 square root 7. Okay, and then we want to simplify the x to the 6th power. Rewrite it as a rational exponent. 6 divided by 2 is 3 with a remainder of 0. So we have x to the 3rd power. Put these together, and then your simplified expression is 6x to the 3rd power with the absolute value sign times the square root of 7. Try the rest of these problems on this page on your own, check your work, and then move on to page 24. Simplify square roots, page 24. If you look at number 1, we have a square root of -1. That's I. So we just have 4i. That's our simplified expression. It's a perfect square here. Let's look at number 7. 6 times the square root of 486. So we want to factor this out. Let's try 4. Doesn't work, so we're going to try the next number. 486 divided by 9. That gives you 54. So 9 times 54. Okay, so we know that 54 is 9 times 6. So we could write this as 6 times the square root of 9 times the square root of 6 times the square root of 6. That's 6 times 3 times 3 times the square root of 6. Multiply that out to get 54 times the square root of 6. On number 8, we have the square root of 180 times y to the 30th power. So first, let's separate the number and the variable, simplify them, and then bring them back together. 180 can be simplified to 9 times 20, and then 20 can be further simplified as 4 times 5. So the square root of 9 times square root 4 times square root 5. 3 times 2 times square root 5. 6 square root 5. And then we'll do y to the 30th power. Rewrite as a rational exponent. 30 divided by 2 is 15 with a remainder of 0. So we have y to the 15th power with absolute value signs with no remainder, so that's just a 1 right there. So then we put these together to get our simplified expression of 6 y to the 15th power times the square root of 5. Pause the video and try the rest of these problems on this page on your own. Check your work and then move on to the next page. Page 25. Combine like terms with square roots. Simplify radicals first if needed. Show steps to simplify the radicals. Let's look at number 4. We have the square root of 96 minus 4 times the square root of 3 plus the square root of 6. So we want to simplify the square root of 96. So let's take our calculator. 96 divided by 4. That gives you 24. 24 is 4 times 6. So then we can rewrite this as 2 times 2, which is 4, 4 square root 6 minus 4 square root 3 plus 1 square root of 6. The first term and the last term are like terms, but the middle term is not because we have a square root of 3 instead of 6. So our answer would be 5 square root 6 minus 4 square root 3. Our answer has 2 terms in it. Let's look at number 6. The square root of 500 minus the square root of 125 plus 3 times the square root of 20. Well, the square root of 500, we could just do 100 times 5. The square root of 100 is 10, and then we have square root 5 left over. 125 is 25 times 5, which that would just be minus 5 square root 5. 20 is 4 times 5. So then we have 2 times 3, which is 6, 6 square root 5. Okay, all three of these are like terms. 10 plus 6 is 16. 16 minus 5 is 11. So our simplified expression is 11 square root 5. Try the rest of these questions on this page on your own. Check your work and then move on to the next page. Page 26. Multiplying expressions with square roots. Multiply each radical expression, then simplify. Show all steps. Let's look at number 2. We have 4 times the square root of 6v squared times the square root of 6v. So for this one, we're going to have 4 times the square root of 6 times v squared times v. We're just multiplying everything on the inside together. Well, 6 times 6 is 36. The square root of 36 is just 6. So we have 4 times 6. The square root of v squared is just v. And then we're left with the square root of v at the end. 4 times 6 is 24. So we have 24 absolute value of v times the square root of v. That's your simplified expression. Let's look at number 4. The square root of 5 times 3t cubed plus 3 times the square root of 10t. We're going to use our distributive property. Multiply each term by the square root of 5. So we would have 3t cubed times the square root of 5, and then we would have plus 3 times 10 times 5 is 50, so we have 50t. 50 can be reduced. 50 is 25 times 2. So we have 5 square root 2. 5 times 3, so we write this. So 5 times 3 is 15. So our simplified expression would be 3t cubed times the square root of 5 plus 15 square root of 2t. You could put the t cubed at the end of this, but just to make it look like it's not underneath the radical, I put it right here. Let's look at one more on this page. Let's look at number 6. We have parentheses 3 plus 2 square root 5r times 2 plus square root of 5r. So we could do box or FOIL with this one. Let's go ahead and do the box method. We'll find the areas of these 4 rectangles. 3 plus 2 square root 5r, 2 plus square root 5r. So the area of the first box is 3 times 2, that's 6. The area of the second box, we have plus 3 square root 5r. The next box, 2 times 2 square root 5r is plus 4 square root 5r. And then the last box, the square roots will cancel out, and you just have 5r times 2, which is 10r. Okay, combine like terms, which would be these two. And then you have 6 plus 7 times the square root of 5r plus 10r. If you were to write it in standard form though, you would write the 6 at the end and the 10r at the front. Try the rest of these on this page on your own. Check your work, and then move on to the next page. Page 27. This is the last page from this video. Simplify imaginary numbers. So I to the 0 power is 1. I to the first power is just the square root of negative 1. I squared is negative 1. I cubed is negative I, and so on. If you ever see a square root that has a negative inside of it, your answer will have an I in it. This doesn't work for cube roots or any odd roots, but it works for even roots. So let's look at number 3. We have the square root of negative 294. We can factor that out as negative 1 times 294. Let's see if we can further factor out 294. Try to divide it by 4. It's a decimal. Let's move on to the next perfect square. So divide by 9. We get a decimal. We're going to try the next perfect square, 25. 294 divided by 25. That's a decimal. And now let's move on to 49. 294 divided by 49. And that gives you 6. So we have the square root of negative 1 times the square root of 49 times the square root of 6. So that's I times 7 times the square root of 6. So our simplified expression is 7I square root of 6. You can also write the I at the end. Just make sure that's not inside the square root. Okay, let's do one more together. 5 times the square root of negative 8. So we want to simplify the square root of negative 8, negative 1 times 8. 8 can further be factored as 4 times 2. So then we have 5 times the square root of negative 1 times the square root of 4 times the square root of 2. So 5 times I times 2 times square root 2. 5 times 2 is 10. our simplified expression is 10I times the square root of 2. Try the rest of these questions on this page on your own, check your work, and then move on to the next section.